Today we're going to be looking at solving equations involving inverse trig functions, specifically the function arctan, or as some people like to write it, tan to the minus 1. What we're going to do is we're going to do two questions. The first question we're going to do the standard way, and the second one, which is the one on the thumbnail, we have to do another way because of a reason which will become evident as we go along. Okay, so first question number one, let's do this the standard way. We have to rearrange this so that we have arctan of x equals pi over 4 minus arctan of 2x, and then what we do is we take the tangent of both sides, so we have the tangent of the arctan of x equals the tangent of pi over 4 minus arctan of 2x. Now the tangent of arctan, because it's inverse, as long as x is greater than minus pi over 2 and less than pi over 2, then the tangent of the arctan just equals x, so that side's easy. Now this side here, we'll look at it as tan a minus b, and we're going to use the formula there. Tan a minus b equals tan a minus tan b over 1 plus tan a tan b. So putting that formula into here, that gives us tan of pi over 4 minus tan of arctan of 2x over 1 plus tan of pi over 4 tan of arctan 2x, and of course tan pi over 4 is equal to 1, so this gives us 1 minus, and again tan of arctan, as long as we're within our range here, is just 1 minus 2x over 1 add 2x, and that equals x. And all we need to do now is solve this quadratic, so we get x add 2x squared equals 1 minus 2x, i.e. 2x squared add 3x minus 1 equals 0. So x equals minus 3 plus or minus the square root of 9 add 4 times 2 over 4, which equals minus 3 plus or minus root 17 over 4. And as x has to be in the range minus pi over 2 to pi over 2, we can ignore the negative. So the answer is x equals minus 3 plus root 17 over 4, and that is the solution to this question here. That's the first one. Now what we're going to do in question 2 is we're just going to basically change that to be pi over 2 instead of pi over 4. And the problem is if we use this method, we will end up here with tan pi over 2 and here with tan pi over 2. Well, that is infinite, and that is the problem. So we have to use a different method for question number 2. Okay, so here's question number 2, which is exactly the same, except it's pi over 2. Okay, so what we're going to do instead, let's just rearrange. So again, it's arctan of x equals pi over 2 minus arctan of 2x. Okay, now we're going to take tangent again. So tan of arctan of x is equal to the tangent of pi over 2 minus arctan of 2x. But what we're going to do now is we're going to look at this. Let's call this tan of pi over 2 minus a. And tan of pi over 2 minus a is equal to sine of pi over 2 minus a over cos of pi over 2 minus a. And for acute a, sine of pi over 2 minus a is equal to cos of a. And cos of pi over 2 minus a is equal to sine a. So therefore our tan of pi over 2 minus a is equal to cos a over sine a, which is cot a. And so therefore basically we can now simplify our question. Well, tan of arctan of x, as long as x is in our range, is equal to x. So we have here that basically x is equal to cot of, so taking here pi over 2 minus arctan is equal to cot, if arctan of 2x is a, is equal to cot of arctan of 2x, and cot of arctan is equal to 1 over tan of arctan of 2x, which equals 2x. So we have x equals 1 over 2x, i.e. x squared is a half, so x is 1 over root 2, and that is the answer to our second question when we have pi over 2. Okay, so basically it's just an interesting thing that we can't use the standard method when we have pi over 2 here, just because we have the tan pi over 2, and so this is a nice little workaround. So if you do get this in an exam, try and remember this, and if you do like this, please like the video and subscribe to the Gresty Academy YouTube channel. Thank you.